This is mathheals.com, where you can find more links to math and computer science YouTube videos. And let's take a look at Newton's method. And we'll do this by example. That's probably about the best way. Okay, so let's look at our first problem. Got f of x is equal to x to the third minus 5x plus 1. And let's say x1 is equal to 2. And this is Newton's method. Now, the first step in Newton's method is to determine your guess. And this will be your x1. We'll see how this corresponds to the calculator in a little bit here. Now, usually you look at the graph and then you try to pick an x value close to where your answer is. Now, what Newton's method is going to give us is the zeros. So if we look at our graph and see where it crosses the x-axis, that's where we're shooting for. Now, in this particular case, they give us a guess of 2. And we're running on the assumption that 2 is fairly close to an x-intercept. Now, x-intercept is the same as the zeros, so we're finding the zeros. Okay, so this one's given. And in step 2, we're going to calculate. We're given our function, but we want to find our derivative. So for this one, x to the third, derivative of that is 3x squared, and then negative 5x gives us negative 5. Then we're going to find x sub n plus 1 using this formula. We got x sub n minus f of x sub n over f prime of x sub n. And now for this particular problem here, they say complete 2 iterations in Newton's method. But we'd actually keep on going until we're done. Now, if I were to plug in for our first one, n is equal to 1. Well, then this would be x sub n plus 1 plus 1. I get it right. And then x sub 1 minus f of x sub 1 over f prime of x sub 1. So I'm just going through, and everywhere I have an n, I'm putting 1 in. So then that gives us x2 is equal to x1. x1 we said was 2 up in step 1 minus f of 2 over f prime of 2. So we got x2 is equal to 2 minus, now our f of x was x to the third minus 5x plus 1. So for f2, we're going to plug 2 in for the x. So we're going to have 2 to the third minus 5 times 2 plus 1 over, and then we got f prime of 2. So we're going to plug 2 into our derivative. So we're going to have 3 times 2 squared minus 5. Now 2 to the third is 8. Negative 5 times 2 is negative 10 plus 1 over 2 squared is 4 times 3 is 12, so 12 minus 5, which gives us 8 minus 10 is negative 2 plus 1 is negative 1. 12 minus 5 gives us 7. So we got 2 plus 1/7. And oftentimes they put this into decimal form, so I'm going to get my calculator here. 2 plus, actually I got it on the calculator, or on the computer. So I got 2 plus 1 divided by 7, enter. And I'll take it out to, I don't know, 5 decimal places maybe. I forget what I did in class. 1, 4, 2, 8, 6. Now, step 4 is going to be repeat step 3 until done. What does that mean, until done? Well, this particular problem here, it said complete 2 iterations. We just did 1 iteration. So I'm going to come back up here, and I'll do my second iteration. N is equal to 2. Well, if I plug 2 in everywhere, I have an n. I'm going to have x sub 2 plus 1 is equal to x sub 2 minus f of x sub 2 over f prime of x sub 2. Now 2 plus 1 gives us 3, so this is x sub 3 is equal to x2. Well, let's see what x2 was. x2 was equal to 2.14286. So I got 2.14286 minus f of 2.14286 over f prime of 2.14286. As you can see, this process will get very tedious. Minus, and I'm going to plug in 2.1414286 into our function. So we're going to have 2.14286 to the third power minus 5 times 2.14286 plus 1 over, and then f prime of that value. So we'll plug that value into our first derivative. So we're going to have 3 times 2.14286 squared minus 5. Now I'm going to plug this in my calculator. And actually, I guess I ought to show it on that calculator so you can see how to enter it. Whenever you're working with the calculator, the TI-83, TI-84 calculator, and you have a fraction that has more than a single number or a single variable on top or bottom, when you plug it in, you have to put parentheses around top and parentheses around the bottom, if you have more than a single number. So let's go plug that in. Okay, so we got 2.14286 minus, and then parentheses around the top part, and then 2.14286 caret 3, because we add that to the third power, minus 5 times 2.14286 plus 1, closing parentheses on the top, divided by beginning parentheses on the bottom, 3 times 2.14286 squared minus 5. Closing parentheses and then enter. And assuming I typed it in correctly, we get 2. I'll take out 5 decimal places again. 12857. Okay, that's 2 iterations, so that'd be our answer. Well, how does this compare to the calculator's way of doing it? Let's go back up to original, f of x. I'm going to come here. I'm going to press my y equals. I've got a lot of junk. That's from Calc 3. Okay. So I'll press y equals, press clear to clear wherever's in that line. And I got x to the third. So x caret 3 minus 5x plus 1. And you have to have 0 on y2. So press the down arrow and put 0 on y2. This process doesn't work unless you put a 0 there. Now if I do second trace and choose intersect, so choose number 5. There's a 0 function too that works different than this. Of course I'm zoomed out, but let me do zoom and choose Z standard, number 6. Okay, now let me do it again. I'll do second trace and I choose intersect. It'll come up and ask us for first curve. We do enter on first curve. It'll ask us for second curve. I'll do enter on second curve. It's asking us for a guess. And, oops, didn't mean to do that. Now, here they told us to plug in x sub 1 is equal to 2. That's our guess. So here I'd be putting in 2. And then I push enter. Now it'll come back with 2.1284, 2.12857. See, ours was starting to converge upon it. So this will give you the zeros, or the x-intercepts, as your case may be, however you want to think of it. The guess you see here corresponds to exactly the guess you see here. So it's doing a numerical method to calculate this. Now there's a little bit more to it than just that, but that's how you can use a calculator to do the same thing. Okay, now this is kind of tedious. You know, we did all this, went through all this. If I had to do like 10 iterations of this, it'd be time consuming, 2 or 3 pages maybe. Well, there's an easier way, and let's talk about it. We come down here, and we got f of x is equal to x to the third minus 5x plus 1. And our derivative is 3x squared minus 5. And we have some kind of guess. x1 is equal to something. Okay, so now x in plus 1 is going to equal to x sub n minus f of x sub n over f prime of x sub n. Well, let's, instead of x sub n, let's and n plus 1, let's put new x is going to equal to x minus f of x over f prime of x. So our new x is going to equal to x minus x to the third minus 5x plus 1 over 3x squared minus 5. Let's first do this in Excel, and then we'll go do it on the calculator. Show different ways of doing it. Okay, so here's going to be my my x values. Here I have x1, x2, x3. I think. Let's see what that gives me. x4, x5. Okay, yeah, there we go. Now initially it's 2. That's our guess. In Excel, we'll do equals, and our new x is going to be our old x, which is that, which in this case is b1. So it's going to be b1 minus, and then when we plug this in, we'll put parentheses on top, parentheses on the bottom. So here's parentheses for the top. Now we got x to the third, so I'm going to have b1 caret 3. That's x to the third. Minus 5 times b1. That's the minus 5x plus 1, and then closing parentheses on top, divided by beginning parentheses on the bottom, and we got 3 times x squared, so we got b1 caret 2, that's the x squared, minus 5, closing parentheses. So that's how we'll enter it in. Basically, just everywhere I had an x, I put in b1. And to do an exponent on the calculator, or on the Excel, you have to do a caret. So I do enter. Now I can fill these down and there's 12 iterations in just a couple of seconds time. Now we came up with this. Let's check our work up here. 2.12857. And you see it converges on the very next iteration. I did 2 iterations. I did this one and this one. The very next iteration is where it converges to its actual value. Okay, let's show how to do this on the calculator now. It's not as slick on the calculator. So this is our idea of what we want to do. And for this problem, our 2 was our guess. Remember, our first one was 2. So I'm going to come over here to the calculator. I want to exit out of that. First thing I'm going to do is press 2, and then I'll press my store button, and then I'll put in an X. So I did 2, store, and then X, and now I'm going to press enter. So I just put 2 in the memory cell X. Well, now I'm going to type this formula in right here. You see, X minus. So I'll do X minus. Beginning parentheses on the top part, and we got X to the third. So X caret 3 minus 5X plus 1. Closing parentheses divided by, and then parentheses on the bottom. And we got 3x squared minus 5. 3x squared minus 5, closing parentheses. Now if I press enter, that gives me my first iteration, 2.14286, 2.1428, and then I had a lot of decimal places. So that'll give you your first iteration. Well, what we immediately want to do is this is our current memory and our answer. You press your store button, and then you push the X key again, and press enter. So I just stored this value in my X location. So now if I do second enter a couple times, it'll bring up that formula again, and you push enter. And it gives us the next iteration, 2.12857. And again, I'll press my store, and then I'll put it in X. Enter. And then I do a second enter a couple times. Second enter goes back to your history, brings up that again. And then if you press enter, there's my next iteration. So it's not as slick as Excel. Excel, you just grab the corner and fill down, and you're done. This you have to do a little bit more, but you can do it. Let's take a look at our second problem. And let me go ahead and save this. We're still going to go through the same steps. And this is Newton's method. So calc 1 Newton's method page 01.pdf. Okay. So now take a look at this one. I'm going to use technology for this. This is number 2, I guess. So we got f of x is equal x to the fourth minus 2x minus 3. Now I need my derivative, so the derivative of that would give us 4x to the third minus 2. I also need a guess. Well, how about if I put 1 in here? Let's see what we've got. 1 to the fourth is 1. Negative 2 times 1 is negative 2. 1 minus 2 is negative 1. And negative 3 gives us negative 4. Yeah, that might be okay. Let's see, if I put 2 in here. 2 to the fourth is 16. Negative 2 times 2 is negative 4. Negative 3 is negative 7. That's further away. If I put 0 in here, that would go away, that would go away, and I'd be left with negative 3. It's probably as good as we're going to get for our initial guess. Okay. Now, if I was doing this by hand, what we'd need to do is x2 would equal to x1 minus f of x1 over f prime of x1. Well, x1 is 1 minus f of 1 over f prime of 1. So we'd have 1 minus, and then we plug 1 into our f of x. So we're going to have 1 to the 4th minus 2 times 1 minus 3 over, then we'll plug 1 into our derivative. So we've got 4 times 1 to the 3rd minus 2. 1 to the 4th is 1. Negative 2 times 1 is negative 2. 1 minus 2 is negative 1. Negative 3 gives us negative 4. And down below here is 4 minus 2, which is 2. Negative negative becomes positive. 4 divided by 2 is 2, so that gives us 3. So then, that's x2. So we just continue up here. Then x3 would equal to x2 minus. That seemed to come out pretty nice. Of course, I guess they are ones, so just nice, I guess. Okay. Now if I go to this next one, so x3 is going to equal to x2 minus f x sub 2 over f prime x sub 2. So we'd have x3 is equal to 3 minus f of 3 over f prime of 3. Because we're plugging in x2, which is 3. So we've got 3 minus, and here we're going to have 3 to the 4th minus 2 times 3 minus 3 over f prime, so we'll plug 3 into that. So we've got 4 times 3 to the 3rd minus 2. That's 81. Negative 2 times 3 is negative 6 minus 3 over 3 to the 3rd is 27. 27 times 4 is something. 108. Assuming I multiplied correctly. Looks right. Minus 2. So then we get 3 minus 81 minus 6 is 75. Minus 3 is 72 over 106. Which would give us, let's see, 3 minus 72 divided by 106. I'll take it to 5 decimal places, 2.32075. So then we continue with our next iteration. So x sub 3 is equal to 2.32075. And then we go to x4 is equal to x3 minus f of x3 over f prime of x3, and so on. You kind of get the idea. Well, let's see how to do it with technology. Okay, let's go over to Excel. And now remember what our formula is going to look like. Our formula looks like the new x is going to equal to our old x minus f of x, which is this right here. So we got x to the 4th minus 2x minus 3 over f prime of x, which is 4x to the 3rd minus 2. Okay, so come over here. What did I say my guess was? I said it was 1. Okay, so I'm starting at 1. Now here I'm going to do equals, and everywhere in this formula right here, everywhere I have an x, I'm going to put in b1, because that's where my guess is, b1. So I'm going to have equals b1 minus, parentheses around the top, and I got b1 carried 4, 4th power, that's the x to the 4th, minus 2 times x, so minus 2 times b1, minus 3, closing parentheses on top, divided by, beginning parentheses on the bottom. And we've got 4 times x to the 3rd, so b1 caret 3, that's the x to the 3rd, minus 2. closing parentheses, enter. And now I'll fill this down. And when it fills it down, it always refers to one right above it. Like this one here, you see it says B1. This one says B2. This one says B3. So it's working its way down. Let's see if that one was right. 2.32075. Yeah, it was. So this is the way you can do it with technology. And that's the way I'd recommend doing it. It's very tedious to do it by hand. Usually you end up programming this or something. It's good to understand the concept and do a few iterations to kind of understand it. Now let's look at it on the calculator. Okay. Remember our guess was 1, wasn't it? So first I'll do 1 and press store, and then I'll store that in X and press enter. Now we're going to type in this formula right here. So we got X minus beginning parentheses on the top part, and we got X to the 4th. So I do X caret 4 minus 2X. This box up here, this formula here is what I'm typing in. So minus 2X minus 3, closing parentheses, divided by, and then parentheses around the bottom. 4x to the 3rd minus 2. So 4x to the 3rd minus 2, closing parentheses. And I press enter. Now when I press enter, currently 1 is stored in X. So it goes ahead and plugs 1 in for X. It gives me 3. Well, I now need to take that value, press the store, and press my X key, and store it in there, and press enter. Now if I do second enter twice, it'll bring up that formula again. I press enter one more time, and it gives us this value, 2.32075. Again, I store that in X. I press the store, press the X, press enter, and I'll do second enter twice. It'll bring up that previous formula again, and I press enter, and that comes up with the next one, which is equal to that right there. So then I'll press store and store it back into the X, and then do second enter twice. It'll bring up your previous formula, and then enter again, and we get 1.645, and so on. So you see how you can use Excel and a TI-3, TI-4 to do this fairly fast, versus kind of hideous doing it by hand. Let me save that. I didn't actually write down my answer on that one. I guess I ought to do that. This here, the 0 we're going to find with this is 1.57474. That's what eventually converged upon. Okay. Now, if you use technology to do this, it's a lot easier because this allows you to find your other zeros. I just merely thought I was done. Let's take a look at the graph of this. We've got x to the 4th, so press y equals, press clear. I got x to the 4th minus 2x minus 3. And I press graph. Now the zeros, or our x-intercepts, is where it crosses the x-axis, which is one right here and one over here. Well, it looks like I found the 1.571. That's this one over on the right side. But let's find this other one. So if we come over here to Excel, I just have to come up here and change my guess. Let me put in -5. See how it's converging upon what looks like -1? So our second second x-intercept is x equals -1. Now the neat part about this is I can put anything in, and it'll work at converging. See, I put -20, which is too far out, and it doesn't converge to -1 in those iterations I have on the screen. But if I put -15, it almost does there, doesn't it? -12, and -12 actually converged to -1. So your guess doesn't necessarily have to be right on top of it, but if you get too far out, you get unpredictable results. Sometimes it doesn't converge, so you do want to choose an x value fairly close to where your answer is. And again, your answer is where it crosses the x-axis. Now, this is not so easy to duplicate in here. You know, we still have this this formula here, so I could like store in -5. So I do -5, store x, and that'll be my new guess. And then I have to do a second enter, and then press enter. Gives me that. And then I have to store it back into x. Do second enter twice. And store that back into x. Do second enter twice. And I'm getting tired of doing that. You can see that if you're kind of far away there, it's tedious. Here in Excel, it's nothing at all, because we put the formula in one place, and then I just grabbed this corner in the lower right hand corner and held down my left mouse button and filled it down. Anyway, let me save that page. And now I guess we're done. There we go. So let me stop the recorders.